Okay, now we also want to consider that different materials will resist the flow of electricity differently, so that silver is the best conductor. Gold, for the same voltage and wire of the same diameter and length, will carry 2/3 as much electricity or current as silver. Aluminum, 4/7 as much as silver. Zinc, 1/4 as much as silver. And nichrome, 1/100 as much as silver. Now that means that gold would have 3/2 of the inherent resistance of silver, aluminum 7/4, and zinc 4 times the inherent resistance of silver. But by inherent resistance, well, we'll make that a little clearer when we define resistivity. Okay, but for now, just think in terms of same voltage, same diameter, same length of wire. These are your comparisons. Now the question we pose is, if you have what length of aluminum is going to carry the same current as a 10 centimeter length of nichrome, given the same voltage and same diameter, etc. Okay, so if they have the same length and diameter, and we're assuming that same voltage, I should say same voltage and diameter, that should be stated. Okay, if they have the same lengths, in other words, if you had a 10 centimeter length of aluminum, it would carry how much more current than nichrome? Well, nichrome carries 1/100th the current of silver, and aluminum carries 4/7 the current of silver, all other things being equal. It turns out then that the nichrome is going to have 100 times the resistance of silver, since it carries 1/100th the current. The aluminum will have 4/7 the resistance of silver, and we can conclude that the same length of nichrome would therefore have 4/7 times 100 times the resistance of the aluminum wire. It follows then that the aluminum wire, that the nichrome is going to have a lot more resistance than aluminum, and the aluminum wire would therefore carry a lot more current if it had the same length. So the aluminum wire is going to have to be longer in order that it'll have more resistance and carry less current. So we can reason that out accordingly. So you can think of how much longer the aluminum would need to be and relate that to your intuition regarding this whole picture. Now the other question is, we could still assume the same voltage and all. How do the currents, we want to order, you're asked to order the currents carried by these wires. Okay? Now, this wire, remember, had 4 times the area, cross-sectional area of this one, but less than 4 times the length, so that it would carry more current. But now, if this is aluminum and this is gold, well, aluminum doesn't carry current as well as gold, so does that make the difference? What's the comparison here? So using these numbers, these ratios, you could reason out the comparison between the aluminum and the silver. Again, this is something I don't want to do on the video. I want you to think about it and work it out. And you make similar comparisons in the others. Sometimes those comparisons are going to be obvious, sometimes they're not. Now, in the problem stated on the document, we also have twice as much voltage on these two wires as we have on these. Now, twice as much voltage on this as on this would make the comparison really obvious. Okay? But let's work it out for the same voltage and all, and then take account that these two have twice the voltage of these two and see how that works out.